Alright, welcome to a video on section 4.3 for pre-calculus, which is looking at trigonometry extended and the circular functions. So to begin with, we have to define what it means for angles to be in the coordinate plane and what it means to have coterminal angles in the coordinate plane. So we have a coordinate plane here. We've got the x-axis, we got the y-axis, you got your four quadrants, you've got your origin, all that jazz. And so a angle, when it's placed in the coordinate plane, is going to have an initial side which starts at the origin and goes in that direction specifically. It goes in the direction of the positive x-axis. This is known as the initial side. Think of it as where the angle starts. And then wherever the angle ends, you're going to have the terminal side, okay? Now, usually when I do this page is I give you guys a little arrow that you put in the middle with like a little brad so you can actually spin it around in your notes. And I might give that to you in another time. But just kind of imagine you've got the terminal side, which could be anywhere. It could be right here. If it was right here, you would have an acute angle. This might be, so theta is the angle. You measure it from the initial side to the terminal side. Okay, but the terminal side might be, I don't know, over here or over here. At that point, you would have an angle that's 180 degrees because it's basically half a circle. But I want you to also imagine that it could go here. And so maybe we're talking about this angle. So something that's greater than 180 degrees. Okay, but I want your imagination to kind of go beyond that. What if we're talking about an angle that goes more than one circle around? Maybe like that, and the terminal side is here. Okay, so if you count by 90 degrees, because that's one quadrant essentially is 90 degrees, you would basically be going 90 degrees and then another 90 and another 90 and another 90 and another 90. So you'd be going all the way around and back. So that would be 900 plus 360 is 450 degrees. So that's where we start to get into this idea of coterminal angles. Okay, you can have multiple angles where the terminal side lands on the same spot. Okay, in mathier terms, two angles are coterminal if they share the same terminal side. Okay, so let's think about, let's start by labeling some of the key angles that are on here. There's these angles called the quadrantal angles. And those are the angles at the axes. So if we're talking about a terminal side that is directly on top of the initial side, we're talking about an angle of 0 degrees, which is also 0 radians. Okay. If we're looking at the top here, this is a right angle. And so this is 90 degrees, which in radians is also pi over 2. Okay, if we go all the way to the other side over here, we're talking about 180 degrees, which is equivalent to pi radians. Going down to the bottom, this is 270 degrees. Just think of it as you're wrapping around 90, 90, 90. That's 390s, so that's 270 degrees. Okay, and in radians, Remember, I think I talked about this with you. You got pi over 2. You count by pi over 2, so this is like 1 pi over 2. This is 2 pi over 2, which is just 1 pi. And then this is 3 pi over 2. Okay. Then if you go all the way around the whole circle, so you're back around, you're at 360 degrees, which is equivalent to 2 pi. Okay. So what if we want some terminal angles? Let's say I want to give a terminal or coterminal angle, not terminal, but coterminal angle for this one, for 270. Is there another way that we can do it? Yes, absolutely. We could go an extra full circle around. So maybe I'll start here and I'll go 90, 180, 270, and then I'll go again 360, another 90, another 90, another 90. Okay, so in that pattern. So essentially what I'm doing is I'm taking 270 and I'm adding a full circle, so 360, and that gives me 630. So 630 would be a coterminal to 270. Okay. Now, another way that we can get coterminal angles, one other thing that we can do is we can use negative angles. Okay. So this is an important idea about angles in the coordinate plane, is the direction. So if we're going in a direction, let me draw it like this. If we're going this way, which is essentially counterclockwise, this is the positive direction. So positive is counterclockwise. So far I've been specifically going in the counterclockwise direction when I'm drawing these angles, and that's because those are the positive ones. If I go in this direction, which is clockwise, this is essentially your negative angles. Okay, so let's see if I can draw this on here. Clockwise is negative. Okay, so that leads us to another way I could describe 270 degrees. If I'm going this direction, I will land there. Hopefully you can see that that's 90 degrees, except I'm going in the clockwise direction, so that's essentially going to be negative 90 degrees, or negative pi over 2. So that's another way that we can get coterminal angles. Okay, so to summarize that up, actually, let me point something about this negative 90 degrees before I move on. If you take 270 degrees and instead of you add a 360, you subtract a 360, you would get the negative 90. So there's still like a 360 involved. Okay, and that's where we are with the summary of how to get coterminal angles. Basically, if your original angle is, say, x degrees or x radians, you can add or subtract some multiple of 360 degrees. Now, I was just going around like an extra time. You can go around like 100 times. You could basically spin, 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 spin your heart's desire and land at the same spot. You're going to get a coterminal angle. It's pretty much infinite. Okay, there's an infinite number of angles that land in the same spot. Okay, so n just represents multiples of 360. If I'm doing it in radians, so if this is in degrees, if I'm doing it in radians, I can add or subtract multiples of 2 pi. Okay, so n just represents some kind of integer. And that's how we're going to get our multiples. Okay, so let's just practice this. Let's name a couple two coterminal angles for each angle. Okay, so 90 degrees. You can add 360 and get 450 degrees. You could subtract 360 So 90 is up here. You could think of it going in the negative direction, and that would be negative 270. And remember, I'm just adding one 360 or one, or adding and subtracting 360 just once. I can add 10 360s. I could add 3,600 degrees to 90. So I get 3,690 degrees. That would be coterminal. And I only asked for two. I'm just giving you extra examples. Okay. Pi. So let's do it in pi, in radians. So pi, you can add on 2 pi and get 3 pi. Okay. You can add, or let's say you subtract 2 pi. So you could do pi minus 2 pi. That would give you negative pi. So negative pi would be negative 180. Okay. Negative 2 pi over 3. First of all, you may not remember which that one is. You can convert it to degrees if it's helpful. Remember to multiply that times 180 over pi. Cancel out the pi's. 3 goes into 180 60 times. That's negative 120 degrees. So just to give you an idea of where you're at, negative 120 degrees is in somewhere in this quadrant. Okay, because you're going this way, 120. So past the 90, somewhere in there. So 30 degrees past the 90 essentially. Okay, so let's add and subtract. Let me get rid of this. 2 pi. So let's say I have negative 2 pi over 3. I'm going to add 2 pi. You're going to want a common denominator. So I'm going to multiply by 3 over 3. And so that gives me 6 pi over 3. Okay, so then adding them together, negative 2 pi plus 6 pi, 4 pi over 3 would be coterminal to that. Okay, or maybe I'll add 4 pi, because that's a multiple of 2 pi, right? So 4 pi, multiply by 3 over 3, I get 12 pi over 3. That gives me 10 pi over 3. Remember, you can find your own examples. There's an infinite number of examples here. Okay, 540 degrees. When they give you a large angle, it's helpful to remember, okay, what is that in something? What is that less than 360? Because you kind of need to know it. So 540, I'm going to subtract 360 from that. Carry the 1. Borrow the 1. Yeah, it's 180. Okay, so if you added, maybe you could also call that negative 180 if you subtract 360. Okay, so those are coterminal angles. So now let's talk about trigonometry in the coordinate plane. So if you imagine this terminal side as like the radius of a circle that has a point on it, then we can start getting right triangles again. So you can kind of drop off that and you get a right triangle. So we kind of talked about this before. It's easy to see the right triangle in the first quadrant, but where's the right triangle over here? It's still there. You just kind of drop it in kind of a different place. Okay, so you drop it here, you got your radius, but it's helpful to understand that there's this point here, and this point has coordinates of x, y, wherever it is. And the x and the y are essentially telling you the legs, wherever it is. So that's what this picture is representing right here. Sorry. Okay, if this point is x comma y, this x coordinate is giving you the leg. Now, what's going to be a little weird about this is we're going to have legs of triangles that are positive and negative. And I know that you're used to thinking of distance as only positive, but for trigonometry in the coordinate plane, don't think of it so much as a distance. So it might not, so it won't be so weird that it's negative, okay? All right, and then you've got the this leg, which would be y. And then we also have a hypotenuse. The hypotenuse here is the radius of, I want you to think of it as a radius, okay? Like a circle, because it's spinning around. So it's r, okay? So we have our 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Recall that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, okay? So start with sine is opposite over hypotenuse. So if our angle is here, our opposite's going to be y, and our hypotenuse is the r. Cosine would be x over r. Tangent would be y over x. Okay. And so y is the y coordinate of the point. Keep that in mind. And x is the x coordinate of the point. And r is this radius thing. Okay, so cosecant is just going to be this one flipped over. So it's r over y. Secant is this one flipped over, r over x. And tangent, cotangent is tangent flipped over, so x over y. Oops, wrong color there. Okay. So now we're gonna get into reference triangles. Okay. So there are all these amazing special right triangles that you know the special right triangles. We've reviewed them. They're all in here. And those are the ones that we need to find. Okay. But before we move on to that, I just want to point out one thing. What if the radius, this r, was 1? If the radius is 1, then that would just turn into y. That would just turn into x. And that's huge right there. Okay, and we're going to get to that in our next class where we're going to lead to that. So for the sake of that simplicity, we're going to make all the radius of this circle 1. So this is 1. All of these are 1. Okay, I'm not going to draw them all the time. Okay, so I'm going to do a little coloring in here. Each one of these little lines is broken up into 15 degrees. Okay. So let's label this circle a little bit. This is the coordinate plane. You got your x-axis, you got your y-axis, all that's the same. This is the origin. This little dotted line represents 15 degrees. There's no special right triangle for 15 degrees, so we're going to kind of ignore that. But I just want you to understand that it's 15 degrees. So the next line is 30 degrees. Now that is a special right triangle that we know, right? If this angle right here is 30 degrees, you get a 30, 60, 90 triangle right here. So I'm going to kind of color this in so you can kind of see it. So this triangle right here is this triangle. We're just separating it out so we can look at it. Okay, so our radius is 1. That means that, so this is the hypotenuse is 1. Remember that the short leg is half of that. So we're just going to call it half. And then to get the long leg, we have to multiply the short leg times the square root of 3. So 1/2 times the square root of 3, or rad 3 over 2, which is how we're going to write it. Okay? So what that tells us is that this point right here is basically we went from the center over the square root of 3 divided by 2 up a half. So that gives us a point right here. This point is, actually let me use the smaller one, this is too thick. This point is rad 3 over 2 comma a half, this point right here. Okay, if you were in my class last year, you should kind of remember this because we did this last year. Okay, so moving on. The next angle, so the next 15 degrees, so from this to this would be 45 degrees. So 45 degrees, and we get a 45, 45, 90 triangle right here. So this triangle right here is a 45, 45, 90 triangle, which is this one. Okay, so again, our hypotenuse is 1. Now, we're used to thinking of it as the hypotenuse is the side of the leg sides times the square root of 2. So we have to undo it. We have to take 1 and divide it by the square root of 2 to get the legs. So then we need to rationalize it. Multiply by the square root of 2 over the square root of 2. And you get the square root of 2 over 2. So our legs are rad 2 over 2, rad 2 over 2, because they're the same. So that point right here, it's over rad 2 over 2, up rad 2 over 2. Because remember, the x and the y of the coordinates are the legs. Okay. All right, one more triangle here that we're going to do in this quadrant is this angle. This is another 30, 60, 90 triangle because we're now up to 60 degrees. So this is 60 degrees. And so that is pretty much the same as this pink triangle here, except it's kind of at a different, it's rotated. So this is 1, this is a half now, and this is rad 3 over 2. So that point is almost the same as this point right here, except switched. It's over a half up rad 3 over 2. Okay. The next angle is 75 degrees. We're just going to ignore that one because it's not special. We know the top right here is 90 degrees. Now that doesn't have a triangle attached to it, but it does have a point. That point, if you were to just plot this point, it would be over 0 up 1. Right? Just going up 1. Just as this point over here is over 1 up 0. Because remember, the radius of this circle is 1. Okay, I'm going to do the next 3 triangles with you, and then I'm going to have you guys finish the rest. Okay, so these 3 triangles here are basically the reflections of those 3 triangles here. So this blue one would reflect right here. Okay, so this triangle is essentially the same, except it's a reflection. And it's also in the second quadrant. The radius is still 1. Except, so yeah, that's still the same, but now notice I'm going left and up. So you could put the 1/2 here in the rad 3 over 2, but the big difference is it's now going to be going left, so that makes this a negative 1/2. Because it's going left a half, so negative 1/2. So this point right here is negative 1/2 up rad 3 over 2. So it's the same except negative for the x value. This angle here, if you count by 15 degrees, so this is 105, this is 120 degrees right here. So the next angle is 135. The next one after that, add 15, is 150 degrees. Okay, and then down here is 180. Okay, so the next triangle for the 135 is a reflection of the 45, 45, 90 triangle. So again, we have the same radius. And when you have to go left, that makes this number negative. So it was rad 2 over 2. Now it's negative rad 2 over 2. Since we're going up, this is positive. So this point right here is negative rad 2 over 2, comma rad 2 over 2. Okay? I would like you to finish this. I think you could do the rest from now on. All right, so I want you to keep in mind that if you flip something upside into the third quadrant here, everything's negative, except the radius will stay 1. And then I want you to consider what's positive and what's negative in the fourth quadrant. Okay, none of the numbers are going to really change. It's just really deciding which one goes where and which is positive and which one's negative. Okay, this is going to lead us to an understanding of something called the unit circle, which we'll talk about next. All right, that's it.